seatbelts on, strap yourselves in. We're going to take a ride. What I want to do is try to explain the difference between average rate of change and instantaneous rate of change. Instantaneous rate of change is going to be very important to you in this class, so we need to understand what it is. So in order to do that, I'm going to set my odometer here to 0. There it is. We're sitting here on my driveway in Lake Shastina. We're going to drive a few miles. We're going to keep track of the distance we go and the time that it takes us. So let's everybody synchronize their watches. Okay, I don't have a watch, but I just wanted to say that. What I do have is a stopwatch, so let me take care of that as well. I'm going to click right here, get going, and I'll see you in just a second as we pick up some speed. So I've driven out of the housing area. I was probably doing mostly 25-30 miles an hour there. Came to a stop sign. I made a left-hand turn. I'm on what's now called Big Springs Road, and right at this moment I'm doing 60 miles an hour right on the nose. And I'm going to just travel down here a bit. I'm going to try to avoid this truck that just pulled out in front of me, and pull over, and we'll talk again in just a few minutes. So see you then. Okay, I just pulled over. I just hit the stopwatch. The stopwatch says 5 minutes 30 seconds. The odometer says 3.2 miles. So I'm going to divide the minutes into the miles. 3.2 miles divided by, what do they say, 5.5 minutes. And that's 0.58. And now I'm going to multiply that quantity by 60 minutes per hour. And what I'm going to get is a speed, 34.9 miles per hour. So what is that quantity? First of all, notice that it only depends on the endpoints of this journey. We started in my driveway with the miles equal to 0, the time equal to 0. Here we are out in the country, 5.5 minutes away, 3.2 miles away. So whatever I did to get here, stopped at that sign, made a left-hand turn, swerved to miss that truck, that information is in that 34.9 minutes, but it's kind of lost. It's kind of lost. So that average speed or average rate of change with respect to distance, get used to saying that, is very different than the 60 miles an hour that I quoted to you just before that truck pulled out in front of me. 60 miles an hour was the speed, according to my speedometer, that we were traveling at that instant. It was our instantaneous rate of change of distance with respect to time. We just typically call that speed. You run into these types of things, instantaneous rates of change, every day, many different times. You just don't recognize that they're different from the average rate of change. That instantaneous rate of change changes all the time. As you saw, I had to slow down shortly thereafter to allow a truck to essentially get out of my way. I sped up after that. So the instantaneous rate of change, it can be constant or it can be changing all of the time. It's a very important quantity to you in differential calculus. I hope you appreciate the difference now between an average rate of change and an instantaneous rate of change. And later, shortly, we'll learn how you calculate those instantaneous rates of change, and I'll give you a little hint. They are limit processes. All right, talk to you later. I got to go back home.